Okay, everyone, this is question number 10. This is the Chapter 4 review. It says, owners of a recreation area are filling a small pond with water. They are adding water at a rate of 25 liters per minute. There are 700 liters in the pond to start. Those are all important bits of information that we need. Let W represent the amount of water in the pond in liters, and let T represent the number of minutes that the water has been added. Write an equation relating W to T, and then graph your equation. All right, so we have the W is going to be the amount of water in the pond, and we're going to say that there are 25 liters, so 25 per minute, so times T, plus to start, there are 700 liters already in the pond. Remember, there's keywords: per, each, and every, and that's going to be the number that's next to a letter telling it how to increase. So if I graph this, I'm going to graph the point 700 first, because that's how much was in the pond to start with. And then I'm going to do a table of values. So T and W. So when the time was 1 minute, 2 minutes, 3 minutes, 4 minutes, 1 minute time would be 25, so I have 725. In 2 minutes, I'm going to have 25 times 2, which is 50, so that's 750. In 3 minutes, it's going to be 25 times 3, that's 75, so I have 775. And in 4 minutes, 25 times 4 is 100, so I would have 800. So I'm going to come over here to 4, and I'm going to graph the point at 800. I think I'm going to go to 2, and I'm going to do 750. That's exactly halfway in between. And then I'm going to graph the other 2 points. 2 and, let's see, 1 and 725 would be halfway between half. And 3 and 775 would be 3/4 of the way. So it would all fall in a straight line like that. Okay, and you would just draw your line. There's the equation, and there's the graph. Okay, so let's look at number 11. It says 3 pumps are pumping fluid at constant rates. For each amount of fluid pumped depends on the time, as shown below. So pump A, they gave us the equation. It's pumping at a rate of 90 liters per hour. So on pump B, we're going to have to find how it's pumping. So I'm going to take the X and the Y and put it in a table going vertically. Just kind of help me out a little bit there. So if I move from 0 to 70, that's an increase of 70. And if I go from 0 to 1, that's an increase of 1. So this pump is moving at a rate of 70 over 1, or 70 liters per hour. Pump C, in 1 hour, it's pumping 80. So this is 80 per hour. So over here on part A, it says, what is the rate of each pump? Well, pump A is at 90. You can see that right here. Pump B is at 70. And pump C is at 80. Okay, part B says, which pump is the fastest? Well, that would be the one with the most per hour, would be pump A. And then C, how much fluid does each pump each one pump in 2 hours. Well, they're giving you the information for 1 hour. So if it pumps 90, pump A pumps 90 in 1 hour, I would multiply that by 2, and I get that it's 180 liters. The second one, 70, I would times it by 2, and I get pump B is 140 liters. If it's 80 and I multiply it by 2, that's at 160 liters for 2 hours. Okay, and that should answer all the questions.